Hello, in this video we will continue with the linked list. At the last video we had a node structure and this creates a new node, and also when you display it, the parameter is the first node, so a pointer to the first node, and by starting from the first node we go all the way to the end of the list, which means as soon as we reach to the null, then we stop. Okay, the problem here is that the elements in a list are dynamic, so that means they may be deleted or some other nodes may be inserted, so we cannot rely on that. So consider that we have AB. What if A is gone from the list? So then we will not know where the rest of it. To avoid this problem, we need another structure, which is list. Okay, the list will keep track of the first item of the elements for the first node. So I say type def. Okay, and so here let me just say so this is a struct, of course, and so because we will not call another list, so here we say next one is node, so we had to use node here, but in here we don't have to. I can just say list in here. Okay, so list, and in here let me have just one field, which is a pointer to a node, and let me name this head. Okay, so this is the list, and we would like to, similar to new node, I would like to create another function, which is new list. Okay, so by saying new list, I will create a list which will be empty at the beginning, so no parameter is needed. And here I will say okay, so I need to create memory. I allocate memory by saying malloc. Okay, so size, the size will be whatever the size of, okay, so size of list. Okay, so this will allocate memory and it will return. So we will assign it to a temporary variable list, and let me name it, so this is a pointer. Okay, so a pointer to list, and let me name it temp or list local. Okay, so a local variable. Okay, so and also its head, so okay, so list local, and its head will be null initially, so we know that it is full, and this will return the address location of the list. So I will say list, a pointer to a list, and then we will return it. So return list local. Okay, so this will create the memory for the list, and then so let's okay, so let me just delete all of this, and let me create a list. So here I will say a list pointer. Okay, so here I will say, let me just say list1. Okay, and so new list. Okay, so semicolon. So this will display that, and also let's okay, so new list. Okay, now let's have a insert item. Okay, so when you insert item, the easier one would be add to the head of the list. Okay, so in here let me just put it here. Actually, do I need this? No, let me just also delete this. Okay, so here I will add a new item. So here it will be void, and let me say add to head. Okay, and in here we need two parameters. The first parameter is which list we are talking to. Okay, so because so you need to specify the list. So this will be a pointer to a list. Let me just say list, and then um, we will we need to create. So this addToHead, this will create a node, and also it will insert it to the beginning of the list. So when you create, we need to specify what information we want to put into the node, and this will be a char. Okay, and let me just say info parameter. Okay, so now here without thinking, so we assume that there is no maximum capacity in the list. So without thinking, I will just create a new node. Okay, new node, and the parameter is whatever we get from here, which is info parameter. Okay, so this will return a address location. Let me assign it to a node pointer, and let me name this new new node. Okay, actually this might confuse you. This is also name of the method. Let me use another name, new pointer. Okay, or how about this, node local. Okay, okay, so node local, and then assignment operator. Okay, so after this, so for example, if we have a b, and when I insert c, c should come before the a. Okay, so this is the new one, and I need to say the next of it will be whatever the head is. If head is a, so the next of this local, so node local, okay, its next will be whatever the head is. Okay, so head. Okay, so after this, also we need to update the list. So when you put C just before the A, so A should not remain a head anymore. So the new head, so list head will be the node local. Okay, node local. Okay, so now let's test it. Okay, so now let's test it. So we have list, and let me just say list one. Okay, actually not this one, I'm sorry. Add to head. Okay, and the first parameter is the list, and second parameter is, let's say, a. Okay, now let's see what happens. Okay, so it seems it worked, but we don't know what happened. So let's write also a function to display the list. So let me just write it somewhere here. Okay, so here I say void, and then so let me name this display list. Okay, and we need to specify which list we are displaying, and let me just name this list. Okay, so here let me just say printf. Okay, and let me just say list items. Okay, and then we will start from the head, and go all the way until the end. So let's do that. So I say while loop. Okay, while the um, the head is not null. Okay, so list head, while it is not null, keep going. Okay, so the statement would be, let's just display it. So print f, so %c, let me put 2 space characters. Okay, and then in here I say, okay, so here I say whatever the head is, okay, whatever the head is, display its information. Okay, so we are not done yet, so we need to update this. So let me say list head equals to list heads next. Okay, and then let's go to the next line, printf. Okay, so go to the next line. Okay, so is there anything missing? Okay, so let's see what happens. So after I insert addToHead, and let me say, actually let me add one more time. So addToHead, let me say B, okay, and then, okay, so and then display it. So display list, list 1. Okay, so now let's see what happens. Okay, so it says B, A. Okay, so it seems that it worked. Okay, so B and A. So now let's display the list one more time. So let me just display it one more time. Okay, so we have a problem. Although we have B and A, it doesn't show that. So the problem is when you display the list, as you see, we modify the head. So this is dangerous. You should not modify the head at all. So here you start from the beginning and at the end head becomes null. And then when you display it again, it says while head is not null, keep going, but we made it null. So to avoid this problem, you should use another pointer. So let me say a pointer to the node, and let me name this ptr. Okay, and then initialize it with the head. Okay, with the head, and then instead of modifying head, just use ptr. Okay, so while ptr is not null, and then here ptr's info. Okay, ptr info, and then update ptr. So move the ptr to the next one. Okay, ptr next. Okay, is there anything else? Okay, now let's run this. Okay, now it worked. BA, BA. Okay, I hope this is clear. Have a nice day.